Hello, hi, good afternoon, everyone. As mentioned, my name is Henry. I'm a lead product manager with the video analytics team over here at Govtech. I hope you're having enjoying a good afternoon over here in Stack. And today, following hot on the heels of our previous topic of CVX, I'll share a little bit about our overall video analytics system, which is basically a platform for video analytics across the whole of government. As you know, with today's technology, agencies are dealing more and more with greater volume of video. This comes about really as largely in terms of improvement of technology, as well as the employment of video analytics, use cases across many agencies and across many different types of diverse usage in terms of deriving of insights, as well as monitoring of situation awareness, as well as in different types of video content that's actually generated by our agencies. However, this leads to a lot of new problems that arises purely from the large volume of data that's now starting to get generated. Essentially, video and image data processing, as you might imagine, in large volumes is manpower and time intensive. A lot of the videos that are generated are maybe very specialized in perspectives, and currently it takes a lot of manual effort to actually eyeball some of these videos, or actually to derive any form of insights that might be useful for agencies to tap into in terms of gathering of inputs or gathering of trends over time, and actually utilizing it for something useful. And then this data processing requires a lot of custom approaches, and even in the terms of curating data that can actually be useful for analytics also takes time and actually lots of manpower. It's also not efficient to zero in on relevant segments of video over such a large volume of data, given the amount of effort that actually is required to zoom in on relevant data points. All of this essentially contributes to an overall rising need for video analytics solutions across the whole of government to mitigate these kind of problems and provide overall more context into our data sets so that we can really derive the relevant data sets for us to do further and more useful things with it. To understand a little bit about the use cases of video analytics in the public sector, it is really quite diverse. As you can see, a couple of examples here that I can mention is, firstly, all of you might be a little bit familiar with the Safe Distance at Parks website, which basically came out during our COVID times. There was essentially a need to understand the volume of people across our public spaces in order to better distribute the public and help inform the public where are the more open spaces that they can go to really enjoy. Of course, in our traditional way of monitoring, this would have been very manual, where essentially NParks officers will have to go down to each of these parks, do a manual count on an ongoing basis, and actually to understand this situation, and much less to put all of this information on a dashboard. So one of the brainwaves that happened was, of course, we have video cameras across all our public spaces. Is there a way to derive these insights and actually automate this process? So of course, we partner with some of our agencies like NParks, actually came out with solutions during this period. We found actually with these cameras, some of the extracted data, such as images from cameras, actually can be utilized in conjunction with video analytics to automatically derive these counts. And by utilizing a very simple setup, we were able to connect all these parks cameras into a video analytics pipeline, which provides these data counts as data into the NParks, which flows into the Safe Distance at Parks website, which then allow us to provide ongoing monitoring on an automated basis across all of our public spaces. And of course, that has been one of the key drivers towards us exploring even new cases. How can we help more and more agencies operationalize in this way? Next, one thing that's very, very dear to, I think, a lot of our hearts is Project Pensive. How can video and image analytics also help us in other spaces, such as medical? As all of you know, Singapore does have an aging population, and we do have a high incidence, rising incidence of dementia across our elderly folks. Could there be any way we can assist in such early diagnosis by automating some of the administering of our monitoring tests for elderly functionalities across time? So one of the projects that we have actually launched into with different different agencies is also an AI-enabled tool to detect early signs of dementia by administering a simple analytics test, with which we will hope to automate using an AI analytics model. And that can provide on-hand results that can help us diagnose early cases of early onsets of dementia and cognitive impairment that could potentially help us lead elderly patients to treatment early. Of course, and this could be another sort of archetype that could also be spread across to other types of illness as well. And of course, that hopefully more use cases that we explore down the road. Another interesting use case is also in exploration of mosquito larvae species. As you know, dengue cases are on the rise in Singapore as well. And every time with rainy season, the way the rain is coming down in chunks these days, it's also very hard to manually collect samples across the island, manually identify which are the samples containing mosquito larvae that is an indicator of which areas in Singapore might be at high risk of more dengue cases. Of course, there are, as you may not be aware, there are definitely more than 20 or maybe even 50 over different types of mosquitoes in Singapore, and only a certain a number of which are actually species that actually spread dengue cases. But every time we count water samples containing mosquito larvae, they may not necessarily be indicative of the dengue population breeding in the area. With that, the agencies controlling these samples actually require a lot of manual processing work in order to dive into and identify these larvae species if they belong to dengue-causing species. And this actually requires expertise of a scientist at the moment in present in order to carry out such analysis. With AI, we are actually able to shorten this time frame by training a model with numerous data sets that allows us to zero in and identify within under a minute target mosquito species that may be at risk of causing dengue in particular, and of course speeding up the sampling process by leaps and bounds. This potentially can increase the coverage of such detection across all of Singapore, and of course increase the amounts of samples that can be processed, leading us to be safer overall. Of course, with such diverse use cases, we find that there are many different pipelines and many different models being developed across our team and in conjunction with many different use cases. Hence, we can see some of the key problem sets across agencies is really, firstly, we need to manage the amounts of volume that's coming in terms of the inputs, in terms of curating the data that can lead to this model generation. Content organization of all of this data that's coming in through all the different input channels is often manual and arbitrary. We do need an efficient way to be able to help us segregate them into logical sample blocks that allows us to then pull it into our model generation pipelines. There's also no efficient way to discover and re-extract relevant sections or segments of video data that we may want to zero in onto. And of course, with different agencies being involved in many of these use cases, we may not also have a single backbone for sharing of this video data across all of government. One example of which was also mentioned earlier by my teammate, Suresh earlier. And of all, the combination of all this is also very important in order for us to be able to build the pipelines to detect the events in the event of analysis or monitoring use cases. It's really difficult to take advantage of existing VA capabilities whereby it may be those three examples that I've shown earlier, or it may be COTS, commercial off-the-shelf VA models that may be available in the industry and market, to bring that into the government ecosystem and really tap on that. There was no central platform that allows all agencies to come in and easily tap on this. There may be cases such as like in the mosquito detection use case, there is also a need to train and operationalize our own custom VA model for video processing. However, there's limited in-house expertise. The operational usage also requires compliance with our government architecture and security standards. With this, we have actually built a whole of government video analytics system called VAS. Hence, we brought all of these under one roof in the hope of bringing a central pipeline to all of government for usage. VAS basically sits on 3 key components: Insights, Video I/O, and Cloud Video Exchange, as mentioned earlier. Insights basically allows any agency to come in and tap onto our various different VA use cases, such as mentioned earlier, that we have developed for different types of reporting and analysis generation purposes. Video I/O, as an end-to-end training pipeline, also allows you to take your own data sets and actually produce your own AI model that can be deployed securely in order for operations in future. And of course, by bringing all this together, we also realize there's another context that also needs to be addressed, is in terms of understanding the context of video content, which allows us to help better curate the data that goes into our video pipelines in order to generate the reports that will be useful for us in operational scenarios. With that, we have launched a new feature on VAS called video indexing. So video indexing basically is allows automatically processes the video and brings together, identifies various key elements of video that gives us more context in terms of objects that may be detected, language, scene segmentation, as well as keywords and topic labels that may be detected within this video. By this, we set out an automated taxonomy that allows you to comb through your video, your video content in order to better curate and select the segments that may be relevant to you. Because video indexing actually serves various diverse user needs in terms of product owners, integration with other systems, as well as for our various operations, marketing exec, policy researchers who actually handle content as well. To give a sneak preview of video indexing on VAS, you can basically log into VAS, pump in your video content, generate a video indexer report, and get this interface. It allows you to easily search across indexes, as well as share your video index with teammates, which will help discovery in future. So I'll move forward. So of course, with Video Indexer now launched on VAS, hopefully those of you in agencies will be onboarding to Video Indexer. We hope to bring this feature more for integration with your video content, and really hope to be able to help you generate insights and actually bridge through your video content in an easier way. And hopefully in future also integrate with your video archives and help and let the metadata drive insights and organization across your video data sets as well. Moving on as well, VAS doesn't just stop there. What we are hoping to achieve is also bring best-of-breed video analytics capabilities under the hood into a common ecosystem for availability to all of government agencies. And with those of you who may be industry partners here who are into video analytics, feel free to reach out to us as well, to how you can participate in this ecosystem. So, as I mentioned earlier, with VAS, we really hope to collaborate foster different approaches towards our collaboration with industry in the near-term future as well. So VAS is part of, as mentioned with CVX earlier, VAS is also part of the SG tech stack, which are basically, as we mentioned, government in the box. With this, we hope to provide a vibrant ecosystem of technology bases across the whole of government, and that allows us to more easily tap into technology on a uniform basis. And with VAS, we sit on both the data science as well as data transfer layer that will hopefully help to propagate data science usage across all of our agencies. And with that, I will conclude my presentation today. Okay, thank you, everyone.